let's jump right into this explainer and reconstruct the 2008 Cessna crash at Bagumpet Airport. This is a true forensic mystery where the tiniest, most easily overlooked details led to an absolutely devastating outcome. What makes this specific case so fascinating and honestly so incredibly tragic is that it wasn't some sudden, catastrophic mechanical failure that doomed the flight. Not at all. Instead, it was a silent, creeping sequence of seemingly minor errors made before the aircraft ever even left the ground. We're going to break down the official investigation report and uncover exactly what happened to flight VT-EMR. Here is our investigation docket for today. We'll start with how the flight went down, move on to inspecting the wreckage, rule out some false leads, uncover the crucial clues hidden in the cockpit, and finally piece together the fatal chain reaction. Part 1. Flight VT-EMR goes down. A routine morning turns tragic. So picture this. It's the morning of September 8th, 2008. A standard training exercise is underway in Hyderabad for a 26-year-old assistant pilot instructor and his 20-year-old student pilot. They're up in a Cessna FA-152, which is a plane practically famous for being a highly reliable trainer. At exactly 11:06 a.m., the air traffic control tower radios over their clearance. The pilot's response? Just a simple, cleared for takeoff VMR. This chillingly routine transmission was the very last message we ever received from that aircraft. It stands in such stark contrast to the sheer tragedy that was about to unfold literally 2 minutes later. There was zero panic in that transmission. Absolutely no hint whatsoever that anything was out of the ordinary. Let's track how rapidly this all escalated. At 9:05 a.m., this exact same aircraft had successfully knocked out an hour-long flight with zero reported issues. Perfectly fine. But flash forward to 11:06 a.m., and observers on the ground noticed something was definitely off. The plane was eating up an abnormal amount of runway just trying to get airborne, and its climb rate was dangerously slow. Then, right at 11:08 a.m., the pilot banked into a sharp left turn way earlier than authorized. The plane just started dropping, rapidly losing altitude, in what was likely a final, heroic split-second decision to avoid crashing into a school playground packed with kids. The pilot aimed for an adjacent road, snagged an electric wire, and went down. Part 2. Inspecting the wreckage. The aftermath in Sanat Nagar. When investigators first rolled up to the localized, severely burnt wreckage, the scene was just grim. The aircraft had come down a mere 1 kilometer from the runway, right in the middle of a thickly populated area. The physical destruction was total. We're talking the tail portion broken clean off near the vertical fin, the propeller spinner completely detached and smashed into a boundary wall, and a severe post-impact fire that just decimated the cockpit. Tragically, neither the instructor nor the young trainee survived. Faced with a totally destroyed aircraft, the investigation team really had their work cut out for them to piece this puzzle back together. Part 3. Ruling out false leads. Eliminating the usual suspects. Now, to get to the true cause, these investigators had to play detective. They needed to methodically clear the board of your classic aviation failure points. Weather? Clear, with 6 kilometers of visibility. Check. Weight? Well within the authorized limit. Maintenance? Passed its daily inspection that very morning. The engine was practically brand new, installed just 7 months prior. And the pilot in command? Fully licensed, boasting over 390 hours of flight time. So we can safely cross all of those off. None of these usual suspects had anything to do with the crash. But here is where the investigation hits a massive fork in the road. Initial visual inspections of the wreckage turned up a cracked engine crankcase and a severely bent crankshaft. To an untrained eye, you see that and think, boom, catastrophic in-flight engine failure, right? Actually, scratch that. We have to completely ignore this false lead. Extensive lab tests, including a full strip examination of the engine, proved definitively that this damage was strictly from the sheer, violent force of slamming into the ground. Forensic science confirmed the engine was in perfect working order before the impact. It was fully capable of flight. Part 4. Clues in the cockpit. The smoking guns. So if the plane was mechanically sound and the weather was beautiful, what on earth happened? Well, the entire climax of this investigation hinges on one specific component, the magneto. Think of it as the aircraft engine's ignition system. For safety redundancy and to generate full engine power, a plane actually has 2 of them, a left and a right. To safely generate the maximum power needed for takeoff, a pilot absolutely must have the ignition switch set to both. Taking off with only one magneto engaged means your engine simply will not and cannot deliver the power you need to climb safely. And folks, Here is our smoking gun. It's a stark, terrifying comparison between the standard, safe checklist procedures and what investigators actually found perfectly preserved in that burnt-out cockpit. Standard operating procedure says flaps at 10 degrees for takeoff. Investigators found the flap switch sitting at 0 degrees, fully up. The procedure strictly dictates magnetos on both. Yet, investigators found the ignition switch locked in the left position. That means only half the ignition system was firing. And just to confirm this wasn't magically knocked out of place during the crash impact, the ignition key was found broken right off inside that exact slot. Part 5. The fatal chain reaction, a cascade of minor missteps. We really have to emphasize this. This wasn't some unpredictable act of God or a freak mechanical breakdown. Let's walk through this tragic domino effect. Step 1, the pilot starts the takeoff roll with the entirely wrong settings, flaps up, and only one magneto firing. Step 2, because of those settings, the aircraft lacks full engine power, and the wings aren't generating optimal lift. Step 3, the plane visibly struggles, chewing through almost the entire runway just to lift off, and climbs incredibly slowly. Step 4, realizing something is terribly, terribly wrong, panic likely sets in. The pilot attempts the sharp left turn at a very low altitude, probably trying to whip around back to the runway. Step 5, that sharp maneuver at such a low speed, heavily compounded by the lack of engine power, causes the wings to instantly lose lift. An unrecoverable stall kicks in, sending them straight into the ground. The official report's final verdict really captures the essence of this tragedy. It states the probable cause was the sharp turn at low height, causing a stall. But the absolute root cause of it all? Non-adherence of recommended operating procedure. Human error inside that cockpit doomed the flight before the wheels ever even left the tarmac. Literally, just a simple glance at a checklist to confirm magnetos, both, and flaps, 10 degrees, would have prevented this entire catastrophe. As we wrap up this explainer, I want to leave you pondering a really vital question. Think about it. How heavily do we rely on standard operating procedures in our own high-stakes environments? And what is the true cost of skipping the checklist? The tragedy of flight VT-EMR serves as a stark, unforgettable reminder that in aviation and honestly in so many other fields, standard procedures aren't just annoying bureaucracy. They are almost always written in blood. Thank you so much for joining me on this deep dive. Make sure to keep questioning, keep learning, and I'll catch you in the next explainer.